Hi, I'm Dr. Skylar L. Anderson, and I'm a professor of digital media arts and game design at the University of St. Thomas in beautiful St. Paul, Minnesota. I want to teach you how to make your own games using GameMaker from start to finish, including publishing. And in this series, I'm going to focus on fundamentals to help you learn the basics of the software so that after the series, you can continue to learn and to make the game you want to make. Let's learn about how to make our object move and controlling the object and how it moves in the game using some simple code. So instances of objects have built-in properties and they appear as green when you write them in the code. So let's add an event to our object. An event is something that happens and code runs in events. So for instance, we can have a create event that runs code for just the moment that the object gets created in the room, or much also very common is a step event. So if we go to add event, step, hover over that, and then click step, not begin step or end step, just normal step, you'll see the step event appear here, and here we have a coding window. Anything that appears in this sort of deep green is a comment, and the code, the game won't read it as code. So anytime you want to write a comment to yourself, write two, I guess you would call them, are they backslashes? I don't know. They're the they're the slashes by the question on the question mark key on my keyboard. But you add two of them, and now you can comment without it being code. But if I write it down here, this would be considered code. And if I try to run the game, this would cause the game to crash. But this will do nothing. So here in the step event, let me first explain what a step event is. A step event is an event that occurs every game frame in your game. A game frame is how often does your game check for instructions. And oftentimes when we're talking about video games, we say we talk about FPS or frames per second. Now, frames per second can mean how many visual frames, but also when we talk about FPS, we can be talking about game frames. In other programs, they call them ticks, but here they are game frames. And if you want to see how what the game frame rate of your project is, you go over to Game Options, click your platform, and we should be able to, oh, see, this is a good opportunity for me. I think it's in Game Options. General. There we go. It's under General, not under Platform. Here, game frames per second is set at 60. You can actually change this, but for now, I would encourage you just to keep it at 60 because that's a very common frame rate. 60 frames per second. Now, in the step event, it will run whatever code you put here 60 times per second, which you're probably thinking, well, why would I want something to be running 60 times per second? Isn't that way too much? Not necessarily. We want it, for instance, we want the game to check 60 times per second whether or not the player is touching a button or not. So that when the player touches a button or tries to control the object, it controls in a way that feels immediate and snappy. So we have the step event here, and we are going to add a built-in property of this object, which is its horizontal location in the room, which you write as X. X for horizontal, Y for vertical. So if we write X equals, let's say 100, that means when we run our game, for the very first game frame that this instance of the object exists, it will basically teleport itself over to here, basically. So I'm looking down here at its X location. It'll be transported over to 100. So I'm going to put the object way over to the left, but when I run the game, you'll see it'll appear way over on the right. And when we run the game, it will appear on the left because of that piece of instruction. Yep, right there. Going back here, but we can also add a movement. So for instance, here we're saying, hey, assign this value to our horizontal position in the room, which I'm just going to start calling X from now on. Assign X to be 100, but we can also write other things like X should be assigned whatever the current X position is plus 1 pixel. So every frame it will check its current position, add 1 pixel to it, and then make that its new position 60 times during the game. So I'm going to open up our game and I'm going to move this all the way to the left because it is going to move to our right, because in GameMaker the count, I guess you would call it, of its horizontal position starts at 0 on the left and moves upwards as you move to the right. So let's run the game. And now we have a moving object. Every game frame 60 times per second, it is moving 1 pixel to the right. Now we're going to replace this code with another way to write this, because normally when we're programming, we don't like to write like this. There's simpler ways to write it. Another way to write it is, instead of writing equals, we write plus equals 1. What this does is that it takes whatever value this currently is and adds 1 to it, just like what we were doing before. If I run the game, you'll see it'll run exactly the same. We can make it go faster by saying, hey, move 2 pixels every frame. Ooh, look at her go. Or if we wanted to go really fast, let's say 5 pixels every frame. Ah! Just to let you know, if you're dealing with just something going up or down by 1, you can make it even simpler by just writing plus plus if you want it to go up by 1 every frame, or minus minus if you want it to go, let me move this over here, if you want it to go left or down. If you want to decrease the value, you can say minus minus afterwards, or plus plus. Now it's moving to the left because over here is 0, over here is 480, and it's moving back and forth. You can also write x minus equals 1. Does the same thing. Now later you can start playing around with systems like multiplies equals, which is going to, if I do this by say 1.5, you'll notice that it will speed up exponentially because it's going to be multiplying itself. Whoa, 60 times per second. It's kind of fun. But for now, I'm just going to say x plus equals 1, right? But we can make this a variable. Now, a variable, if you remember from algebra, is just anything that stands in for something else. And in programming, we can give it names that make sense to us. So for instance, we're going to have this be given a name that we can change, basically. We're going to add an event, and we're going to declare a variable. Declaring a variable in the create event allows us to manipulate that variable from frame to frame and have the game hold on to it in memory. So we're going to click add event, go to create. Here we have a new tab. And what I like to do is that I like to click and drag create all the way to the left, because it reminds me that this is code that runs precisely one time when the instance of the object gets created and then never runs again. After that, the steps take over. So here I'm going to declare a variable by writing a name that I'm going to give our horizontal speed value. I'm going to not call it horizontal speed, even though I could. Horizontal speed could equal 2, right? In fact, let's actually call it that right now. And I'm going to just highlight Control C to copy it, move over here and paste it where the 1 is. I'm going to shorten this in a moment, but I just want to see that the principle still applies. So horizontal speed is 2. So wherever the GameMaker sees this variable, it's going to place the number 2 there in this object. Now this is declared in this object, so only this object can use this variable. And you'll see that it will move 2 pixels per frame. Now in my sort of system of coding, I've come up with certain names that I like to use. Well, I didn't come up with this one. This one came from Sarah Spalding on YouTube. But instead of writing horizontal speed, I write HSP. And I just know from years of working in GameMaker that when I write HSP, it stands for horizontal speed. So over here, I'm going to rename this to HSP. and run the game. Make sure I didn't introduce a typo. Yep. So now we can change what HSP is during the game so we can control how it moves horizontally. So we are going to go back to our create event, and we are going to write a bunch of things. We're going to declare some variables. HSP, standing for horizontal speed, equals 0, semicolon. I'm going to add a comment, 2 slashes, horizontal speed. VSP stands for vertical speed. I'm going to write equals 0, semicolon, vertical speed. And then move speed equals 3, semicolon. This is going to be my top move speed. I guess here a better comment would be current horizontal speed, current vertical speed, and then this is our top move speed, or our maximum move speed. Now in the step event, I'm just going to delete that, and I'm going to write some code. So first I'm going to add a comment and write get inputs, and write var space underscore key underscore left equals keyboard underscore check, open parentheses, vk underscore left, close parentheses, semicolon. Now that may seem like a lot if you're new to things, but let me walk you through. What's this var thing? Well, remember how I said that when we create these variables here, these are variables that sort of carry over from frame to frame, and as long as an instance of this object exists in the game, GameMaker will be holding onto these values in memory, and we can manipulate them during the game. However, this is a different type of variable. It is called a local or temporary variable. I call them local variables. And local variables get created this frame, and then GameMaker can stop thinking about it every other frame unless we need GameMaker to. So this is a variable that we don't need GameMaker to remember from frame to frame because we want it to be checking every game frame whether we're holding the left arrow key on the keyboard. The reason I start the name with an underscore is just a naming convention. I don't have to have the underscore there. It just helps me remember that I'm working with a local or temporary variable. I could have just written var key left equals keyboard check. But just a naming convention that I use is I add an underscore whenever I'm using a local variable, just to keep things straight that this is different than a variable that stays in memory. Now, what value I'm assigning to this variable is whatever this function creates. So this function is called keyboard check. And what it does is that it checks to see if a keyboard key is being currently held down during this game frame. And the key that it's going to check is the left arrow key, which is called VK left. Now, you might be wondering, like, what are the other keys? Well, this is a great example of a time when you can read the help manual or the documentation to learn more. So if I hover over VK left and click with my scroll wheel, and then I'm going to move this over to where you can see it. Keyboard input, and you can see a bunch of constants or names for different keys on the keyboard that you can use. VK underscore whatever. You can also use another function if you want to use a letter on your keyboard, but I'll teach you how to do that later. So I'm going to keep writing. Var key right equals keyboard check VK right. And now I have these two variables that I can check, and these functions are going to return true or the number 1, or false or the number 0. So in GameMaker, it does not distinguish between 1 and 0 and on and off or true or false. That's just what it checks. So I can this returns or creates the number 1. So when the left arrow key is being pressed, this value is going to be true or 1. And when it's not being pressed, it will be false or 0. New comment, calculate horizontal movement. Another comment, get directions. Get direction. -1 is left, 1 is right, 0 is nothing. And then another piece of code, var underscore hdir, which I'm calling horizontal direction, equals underscore key right minus underscore key left. So if both of these values are 1 or a 0, depending on what key is being held, if I'm holding down the right key but not the left key, it'll be 1 minus 0, so hdir will be 1. If I'm holding down the left key but not the right key, it'll be 0 minus 1, so hdir will be negative 1. If neither key is being held, 0 minus 0, then hdir would be 0. Or if both keys are being held, 1 minus 1, this would also be 0. So this is just an easy way for me to check the horizontal direction. Negative 1 being left, 1 being right, 0 being nothing. New comment. Set move speed with direction. Here we go where we actually manipulate our current horizontal speed variable that we declared here in the create event. We can write HSP equals underscore hdir multiplied, you add an asterisk to multiply things in GameMaker, move speed. So this will take the direction, negative 1, 1, or 0, and multiply that by our move speed variable, which is currently set at 3. So if I'm holding the right arrow key, 1 times move speed, it'll assign HSP to be 3, positive 3. If we're holding the left arrow key, it'll be negative 1 times 3, or negative 3. So HSP would be negative 3, or it would be 0 if hdir is 0. And lastly, comment, commit to horizontal movement. X plus equals HSP. Whew, now we have some code that allows us to control where the block of, or where O player goes. Let's run the game. If I hold down the right arrow key, left arrow key, I'm going to hold the right arrow key and then press the left arrow key. Stops moving. Lift up 1. Look at that. We're controlling something. Now remember that HSP will be 0 if we're not holding any key down, and X, if you add 0 to the current value, it means that the X position will just stay exactly where it is. Excuse me. So let's add some vertical movement with the same principles, right? Under get inputs, we'll write var. I'm going to go a little faster here. Key up equals keyboard check VK up. Var key down equals keyboard check VK down. And now I'm going to highlight and copy all of this, copy, and then underneath this, I'm going to write a comment, calculate vertical movement. I'm going to paste it, Control C and Control V, right? And I am going to just change some values here. I'm going to change this from hdir to vdir. You'll notice there's a little yellow squiggly there. It's because we have a local variable that's already been declared as hdir. So this is telling me, hey, you can't use this name. It's already been declared. You can't redeclare it. So I'm going to change the h to a v. So it's going to be vdir. And I'm going to change key right to be key down and key left to be key up. Let me explain to you why. If we go to our game, if you'll notice down here is the location of O player. If I place it near the top, the location of O player is 0. If I move it down, it gets higher. So in GameMaker, for up and down coordinates, 0 is the top, and that it increases as you go down. So that's something that some people need to get familiar with. It's a little counterintuitive if you're not used to thinking about up and down directions like that. But 0 is up here for vertical, and then 0 is to the left for horizontal. Now, for those of us who read left to right in whatever culture or language we speak, like in English, that makes sense. But 0 up here going down, it makes sense also if you think about reading on a page, that you start at the top of the page and go down as you read. So that's why we have to put key down first, because key down is going to be our positive number. So if key down is being pressed, minus 0 will be positive, and so we'll be going down in the room. However, if key down is not being pressed and key up is being pressed, it'll be a negative number, and negative means going up. Lastly, I'm going to change this to VSP instead of HSP, change this to VDIR times move speed, and change this to Y plus equals VSP. So I'm going to just recheck here, make sure I've changed everything. VDIR, key down, key up, VSP, VDIR, Y plus equals VSP. Yes, that is all correct. And so if I run the game, I should be able to use the arrow keys to move up and down and left and right. And look, we are moving and we are grooving. We are having fun. Let's now add collisions. Collisions are when objects stop other objects from moving. And so we don't want to be able to leave the room, leave this area. So right now I can actually control this object and have it leave the boundaries of the game. We don't want that, right? So we are going to add collisions. I'm going to close this because, again, I like to keep my workspace nice and tidy. And we're going to create a new sprite, call it S block, set the size to be, see, what do my notes say, 30 by 30, apply, set the FPS to be 0, set the origin to be top left origin. Keep it top left. In fact, I want to check S player, make sure, S player, we need to change this back to be middle center. From my last video, I did not change this back to be middle center. We need S player to be middle center for reasons that will be made clear later. Now back to S block. Origin will be top left, and now we need to fill it with a solid color. Now for a collision block, I'm going to choose a sort of banal gray. Or like sort of there we go, banal, sort of muted. There we go. And I also like to add some lines here. Oh, let's do it a little brighter, eh? And I like to add boundaries. Again, you don't have to do this. You can just keep it a solid color. This is just what I like to do. Just what I like to do. Again, the origin is top left, FPS is 0. Very good. Now we create a new object, call it O block, and we assign the corresponding sprite. Now you can see why we have this naming convention, because we have sprites called S player and S block, and we have objects called O player and O block, and it's very easy to keep them distinct and separate. Now in our game room, we're going to add a layer that we're going to use to put all of our collisions. Now, much like with GIMP or Photoshop or image manipulators, GameMaker operates with layers. The layers section is over here. If you ever lose track of this, you can just click the name of the game room up here and it'll pull up properties, right? So if I have the sprite editor, actually, this still has the layers. Never mind. But you can see we have two layers right now. We have an instances layer, which means instances of objects, and we have a background layer, which is just this black background color. And you can add images to backgrounds, etc. I'm going to keep this as is. I'm going to re-click the instances layer, and we're going to add another instances layer. So if you go down here with this little plus sign, click that, and you can see there are 7 different types of layers we can add. And we're going to add another instance layer, and we'll call this collisions. You can rename things by, again, right-clicking or hitting F2 when you've selected it. But I'm going to click our collisions layer and drag it underneath our instances layer, because whatever is up top is closer to the player and whatever is below it is further away from the player. So it's just a good way to keep track of where things are located or layered in the room. In our collisions layer, we're going to set the grid to be 30 by 30 because our S block sprite has a top left origin and it's 30 by 30. It should snap perfectly to this grid. And I'm going to select O block, hold down the Alt key, and then I can paint with it. And I'm going to create a border that we cannot cross. Beautiful. Now I made sure that the collisions layer was selected when I added our collision blocks. What's great is that I can hold shift and select everything here and hit delete, and it doesn't delete O player because O player is in a different layer. go back here, and I just hit Control Z to undo that. Now back over here, I can close that. Let's run the game, make sure that we haven't introduced any bugs. Yes, very good. Now, right now we can move over the blocks, but we will change that momentarily. Now for the collision code. Let's go open up OPlayer step event. I'm going to take a sip of my tea, hold on. Got to keep myself hydrated, lubricated if I'm talking so much. Now, right here where we say commit to horizontal movement, right above it, I will write our collision code for horizontal movement. New comment, horizontal collision. And now this is the first time you will see if. If is a way of checking for a condition, and if that condition is true, it will run the code, and if that condition is false, it will ignore the code. A lot of people call these if-then statements, but these are conditions. So I'm going to add a condition for our code. If, and in here, we could literally write true, open curly bracket, close curly bracket. And whenever we have a condition, the condition, we like to put it in parentheses so we can keep track of it, and then have open curly bracket and a close curly bracket that is in line with wherever the if condition is. So we can just keep track of it. And you'll notice that I'll be hitting tab to indent things. Please follow how I indent things so that you can always keep track of what conditions you're actually manipulating. GameMaker helps you. If I highlight this bottom curly bracket, it also highlights the top curly bracket so we can see what we're working in. We can add code here because this will always be returning true because I wrote true, or if I wrote 1, it would be also true. But if I wrote false, it would ignore everything in this. So for instance, I can write game end and unreachable code. How about room restart? Oh, it doesn't like that. Let me put just if 1 equals 1. There we go. So I'm going to do a test here. Now, whenever we put condition or code within a condition, I always indent one layer by hitting tab. So here I'm going to write if 1 equals 2, this is not a true statement, so it will not restart the game. So if this code runs, it's going to actually crash the game. But I'm going to run it, and our game works fine. Nothing's happening. Or I can write game end. Also, 1 equals 2 is false, so this code will be ignored. I can run the game, and that code will be safely ignored. But the moment I make it a true statement, like 1 equals 1, and just a thing is that when you're not assigning something, if you're doing a check, we write 2 equal signs. I'm sorry about that. 1 double equal sign 1. We run the game, and it will immediately close the game because it ran this code. So what is the condition we're going to check for? We're going to use a function called place underscore meeting, open and close parentheses, because we need to add some instructions. What place meeting does is that it checks to see if an instance of an object is overlapping an instance of another object. So for instance, if I said, hey, if, let me go back over to instances. Hey, if place meeting OPlayer overlaps with OBlock, then run this code. And if it doesn't overlap, ignore this code. Similarly, we can check for the opposite of that, but we'll do that in a moment. But we need to give it some instructions. You'll notice down here the arguments that it needs. It needs an X and a Y location to check, and then the object. And what this does, it creates a hypothetical situation where it says, hey, if OPlayer, which is the object that's running the code, if OPlayer is at a particular X position and a particular Y position, would it be overlapping with the object that I list? So we're going to write X plus HSP as the X location, and then just Y for the Y location. And the object we want to check against is O block. If our O player's X position plus its horizontal speed, so say we're moving to the right and we're 2 pixels away. So our move speed is 3. So hey, if our current position plus 3, 1, 2, 3, overlaps with the block at the same Y position, then run this code. So this is what we want to check. We want to check for a collision. Hey, if wherever we are plus what we're about to move overlaps the block, run this collision code. And we're going to write the collision code here. In fact, I'm going to add a comment right here and write if next frame will overlap with O block. Then here we can write a local variable, var underscore 1 pixel equals sign of HSP semicolon. Now what this does is that first we declare a local variable that will only exist within this particular condition. And we're using a function called sign. Now what sign does is checks to see if this value is positive or negative. If HSP is positive, it will return the number 1. If it is negative, it will return the number -1. So basically we just want 1 pixel to be 1 if we're moving to the right, or -1 if we're moving to the left. Next line, actually I will add a comment here. Get a 1 or a -1 based on movement. Next line, while. Now while conditions are interesting, I'll explain it in a moment, but let me write this first. While, and then write an exclamation point, place meeting. Now what this does is when you write an exclamation point, we call it in coding, we call it a bang. So from now on, when you see this, think of the word bang. So while bang place meeting, what that does, it says, hey, the opposite of this, or as if the following thing is false, meaning if we are not overlapping. So if we're not place meeting X plus 1 pixel, that local variable we just wrote, comma Y, comma O block, close parentheses, open curly bracket, and close curly bracket. Now, while is an interesting condition. What while does is that it says, hey, as long as this condition is logical, as long as this condition is true, run this code and repeat it during the same game frame until this stops being true. So this is a great way of repeating code until we need it to not repeat anymore. So what this will do is that all in the same game frame, say I'm 2 pixels away, right? And HSP is going to be 3. And we've already decided that if in 3 pixels, I'd be overlapping a block, right? So what this does is says, hey, if you add a pixel to our X position and we're not overlapping with O block, then do the following code, which is X plus equals 1 pixel, which means move a pixel. So it says, okay, if I move a pixel, will I be overlapping the block? No? Okay, then move. Checks again. Again, while loops are called while loops because they're going to loop through this code again and again until the condition returns false. All right, so in 1 more pixel, will we be overlapping? No? All right, move 1 more pixel. All right, and if we move 1 more pixel, will we be overlapping? Yes, we will be. All right, this condition is no longer met, so it won't run the code, and then we can proceed. And then we can say HSP equals 0, semicolon. I'll add a comment, stop movement. And then right here, it says we commit to horizontal movement. And so this will basically, again, check to see if we're about to overlap with O block. It'll check the direction we're going and assign that direction be +1 or -1 to this local variable called 1 pixel. Then it will do a while loop where we'll move 1 pixel that direction over and over until we stop, until we're not going to, until we're about to overlap with the block, but it stops before we overlap with the block. And then it changes HSP to 0, so we stop moving horizontally. And then, yeah, we commit to movement. So this should stop horizontal movement. So if I, oh, see that? I cannot move left or right through the block. Now, this is quite a universally used collision system in a lot of different GameMaker tutorials. There's different ways to format it. This is the way I like to format it. But one thing you should take note of is that we should do the horizontal collision check and then commit to horizontal movement and then calculate vertical movement. And we're going to add the collision, vertical collision right before we commit to vertical movement also. So to do that, there's 2 ways to do it. You can write this all out again with different values for vertical movement. You can also copy and paste this and change things. I think for most new people to GameMaker, they end up forgetting to change something. I know what to change because I've used this code a lot. So let's just retype it right here. So I'm going to write vertical collision if place meeting x, y plus VSP O block, close parentheses, open curly bracket, close curly bracket, indent, var 1 pixel equals sign VSP, semicolon, while bang, place meeting, open parentheses, x, comma, y plus 1 pixel, comma, O block, close parentheses, open curly bracket, close curly bracket, indent again, y plus equals 1 pixel. Yep. Does this change yellow? There we go. And then underneath that, VSP equals 0, and then commit to movement. Whew, I think I did that correctly. So let's run the game. And now we have vertical and horizontal movement even when going diagonally. So you'll notice if I'm moving diagonally, it sort of stops and we can continue to move horizontally. It is a lovely collision system. Now, just because I'm doing so much with my mouse, and then later in the tutorial, we're going to add a shooting mechanic where we use the mouse. So I'm going to actually change what keys move our OPlayer object to letters on the keyboard. And to do that, since they're not constants, we have to use another function called ORD. We're going to write ORD, open and close parentheses, and within that, write a quote, and then the letter you want to use, in this case A for me, then close quote. And there you go. So you can replace all these with letters. I'm going to change these to WASD on the keyboard so I can do it with my right hand. So ORD, open parentheses, open quote. This will be key right, so that's the letter D. Close quote, close parentheses. And then just to make things simpler, I'm just going to copy this and just paste it in here and just replace the letter. Key up will be W, and then key down will be S. Now let's run the game and see if our WASD controls work accordingly. Yes. You don't have to do that. You can keep it as the arrow keys if you'd like. I just think that this is going to be much more convenient for me as I'm testing the game. And now let's tidy up our code. Now you'll notice we have a lot of code happening right now, and GameMaker has a wonderful system to minimize and maximize sections of code that you want to see or don't want to see. So those are called regions. So I'm going to put my cursor there and hit return or enter a couple of times, and I'm going to write up here sort of a number sign, write region, space, and I'm going to write inputs in all caps. You don't have to put this in all caps. You can name it whatever you like. And then wherever we're done checking for inputs, I'm going to write number sign and region. And now if you give it a second, GameMaker will notice that we've added this, and now I can click this little minimize button and minimize that and expand it for when I need it. Same here. This is going to be called region, region horizontal movement. And then that ends right after we commit to movement, end region. And I always like to add a full line break between so everything looks nice and clean. region vertical movement. Then down here, and region. So now we can minimize, and look how clean it is. Now if I want to mess with my vertical movement code, I can just expand that, work on it, and then close it. If I want to change inputs, I can open that, change things, and then close it. Keeps things nice and clean. Now for our first opportunity for what I'm calling advanced practice. Now what I'm about to teach, you don't feel pressure to learn it. If this has been overwhelming thus far, just watch this, but don't follow along if you don't want to. This is called advanced practice for a reason. I'm going to be introducing some more advanced practices, some things you can do to make things more polished and more professional that requires slightly more programming skill. You can always come back and implement these later, but if you're just learning programming or just learning GameMaker, just ignore what I'm about to teach for the rest of the video, basically. So from here until the rest of the video, you can just do this or not do it. Either way, when we pick up on the next video, you'll be able to just keep going and just ignore what we just did here. So advanced practice, we're going to add momentum-based movement. Let me take a sip of my tea. There we go. Keep my throat hydrated and lubricated since I'm talking so much. So a lot of movement mechanics in games aren't as, let's call it, mechanical or discrete or stiff as hold a key and you're immediately going that speed, right? Like platforming games, other games, most often it's a momentum-based system, which means when you start movement, you're going a little slower until you reach your top speed. And when you let go of movement keys, it takes a few moments where it slowly slows down to a stop. So we're going to do that by going to the create event and declaring some variables, an acceleration and deceleration value. So accel equals 0.1 semicolon, comment acceleration, how much to add to momentum, and then decel equals 0.05, deceleration, how much to decrease momentum. Now back to the step event. In the step event, where we do this code right here, where it says set move speed with direction, we're going to replace it with the following. I'm just going to delete the comment and this line of code and instead write a comment, add accel to HSP, negative adds momentum to left, positive to right. And then write the code HSP plus equals hdir times accel. Now run the game. Oh, WASD. Ooh, things are so slippery. And when I let go, we just keep moving until we reach a collision. But don't worry, we haven't added the deceleration code yet or the max speed yet. So right now I can sort of speed up to as fast as I can go. To slow down when we're not pressing left or right, right under here, we're going to write comment slow down, oh player, if no direction key is pressed. If hdir double equal sign. Now again, in conditions, when we're doing a check to see if something equals something else, we always write two equal signs and we reserve a single equal sign if we are manipulating a variable. So hdir double equal sign 0, open curly bracket, close curly bracket, add a comment, no direction pressed or both pressed. If HSP is less than, we do a less than symbol, 0, open curly bracket, close curly bracket, meaning, I'll add a comment here, meaning going left. HSP equals, and now this is a really cool function called min, open parentheses, HSP plus decel, comma, 0, close parentheses, semicolon. So min is a really cool function. You can click on it with your scroll button to read more about it, or you can just hover over here to read a little bit about it. What it does is that it checks which of these two values, or any number of values, you can keep adding values negative 300 here as much as you want. And it looks at this list of values and it returns or gives back whichever one is the smallest. So in this case, it would be negative 300 because that's the smallest number. But here, by writing minimum of HSP plus decel or 0, we can do a cool thing where it slowly increases its value until we hit 0, whichever one is less. So for instance, we're going to the left, right? So already HSP is negative, right? So say we're going negative 3, HSP is negative 3, negative 3 plus, what's our decel value? 0.05. Negative 3 plus 0.05 would get us negative 2.95, right? Negative 2.95. And it asks, hey, which is smaller, negative 2.95 or 0? Well, negative 2.95. So now HSP is negative 2.95. Next frame, negative 2.95 plus 0.5 would make it negative 2.90. And then it asks again, which one is smaller, that value or 0? Well, this is. And it'll just keep on adding decel until it reaches 0. So it's just a great way to gradually approach the number you want to approach. So that's going left. And then we can write else here. And this is the first time we've encountered an else statement. Else is a way of saying, hey, if this is true, do this. Otherwise, do this. It's a way of capturing everything else. So, hey, if this condition is true, do this code. But if anything else is any other condition, if this any other situation, do the following code. So here we already know that no direction key is pressed. So if HSP is less than 0, if HSP is negative, do this. But if HSP is positive, basically, do the other code. So I'm going to write under else, I'll write going right. HSP, actually, do you know what? This also includes not going anywhere, right? Because you could equal 0. Anyway, going right, HSP equals same thing, except instead of min, we'll write max. Max HSP minus decel, comma, 0. Same principle, but in reverse. It's whichever of these values is bigger. So if HSP is positive, minus decel, whichever one is bigger, it will return and assign to HSP until we reach 0. So we can run the game and that will slow things down for us. So if I go left and then let go, whoop. Now we still don't have a top speed that we can use to cap the speed. So let's cap it. Underneath here, we can write a comment set max horizontal speed and write HSP equals, and this is a great function called clamp. Clamp makes sure that a certain value never exceeds certain parameters. So this requires 3 arguments, which is the value we want to clamp, which is HSP, and then the minimum we ever would want it to be, and in this case it'll be negative move speed, and then the maximum of what we would want it to be, which is just move speed. So this function will return a number, and that number will be, first it'll check whatever HSP currently is, and then it'll say, hey, is this value within -3 or within +3? Whatever it is, let's set that to be the value. So this HSP will never be bigger or smaller than move speed or negative move speed. Let's run the game. If you remember, move speed is set to 3. So now when I move left, it caps our move speed at 3, moving left and right. Now for vertical movement, we can copy the entire horizontal movement section. So I'm going to just start here and copy it. And I'm going to go all the way up to here. So the direction, that stays the same, and the collision, that stays the same, but everything else I'm going to copy And I'm going to go over down to vertical movement and replace the section that says set move speed with direction. I'm going to delete that and its line of code and paste. And I'm going to change all these values accordingly. So HSP changes to VSP, HDIR changes to VDIR, HDIR changes to VDIR, HSP changes to VSP, 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 VSP. And now, when we run the game, it should work with vertical movement as well. Now note, you can play around with the acceleration and deceleration variables in the create event to get movement that you like. This works for the kind of game I'm imagining for this project, so I'm going to keep it where it is. Now, remember, while this window is 960 by 540 pixels, our actual game is only 480 pixels by 280 pixels. So the movement might jerk or look a little funky. It's sort of artificially stretching our game. But one thing I like to do in my pixel art games is make sure that the horizontal and vertical position of any object is on an integer number, because GameMaker can actually handle sub-pixel movement. Like you can assign a horizontal position of 1.7 instead of 1 or a 2. And it can handle that. Now it'll sort of stretch or cut off whatever art assets you have. It'll try to approximate where it should look. But with these super small, crunchy pixel art games, I like to make it so that no matter where it is, it's always landing on a full integer horizontal and vertical number. So while subpixel movement is great for sort of bigger games, I would say if you're starting a game resolution at 720p or bigger, don't worry about subpixel movement. It looks fine. For such a small pixel art game, you should address it. So this is how I like to do it. I'm going to go to the create event, and I'm going to declare two new variables. I'm going to call this xReal equals x, and I'm going to call this with a comment, the real location of OPlayer. Y real equals y, the real location of OPlayer. So I'm going to use these variables, xReal and yReal, to keep track of sub-pixel movements, but then I'm going to separate that from what it shows us on the screen, right? So we're going to go over to the step event. Let's go back to the horizontal movement section where it says commit to movement, commit to horizontal movement. And we're going to write, instead of x plus equals HSP, we're going to write x underscore real plus equals HSP. And then right underneath that, I'm going to write x equals round x real. Round is a great function. What it does is that it takes whatever value that you put into it, and if that value is in between integers, it rounds up or down to the nearest possible integer. Now, there's other rounding functions that you can use, like floor. Floor is a great function that always rounds down, and then there's one that always rounds up. You can read about that if you middle sort of scroll wheel click that and read about the other things you can do. I like round. It's just round as a general purpose rounding function. And so I'll always be using xReal, but what we put on the screen graphically will always be an integer number. Now also down here, we're going to scroll down to where we commit to vertical movement and change that also y underscore real plus equals VSP. And then underneath that, y equals round y real. This is a good place to mention that the code in the step event runs top to bottom. And so if you're manipulating a variable like HSP or VSP, you can do things to that variable up top, and then you can manipulate it as you go down. And in the step event, it goes through the entire step event top to bottom, each game frame. So that's why we can keep messing around with VSP, yReal, y, etc. Now, this is going to cause some collision issues. I'm going to show you why, because we need to adjust our collision code. But if I try to move I get stuck, right, very quickly, because it is changing my y location, but its yReal location is different. So there's a very easy way to make sure everything is cohesive, and that is to go to our collision code. Let's start with our horizontal collision, and basically anywhere you see x or y throughout the entire step event, we replace it with underscore real. So I'm going to just highlight underscore real and copy it. And anytime I see X or Y, I'm just going to paste it there. Because the only time we actually need to assign the actual X position is here, where it rounds the X real value. Scrolling down to other collision code. Just any time we see an X or a Y, add underscore real next to it. There we go. Now we can run the game, I think, and we no longer have collision issues. Now you're going to notice some jaggedness with the movement. That's because of the subpixel movement. If it's between pixels, it's going to sort of stay in its position until it lands at another integer value. But for small, crunchy pixel art games, that's actually a look I prefer because it keeps all the artwork pixel perfect at all times. None of the artwork is getting stretched or changed or clipped. And this is what actually a pixel art game should look like. So every pixel is a pixel in a pixel art game. I like very true to life pixel art games. You don't have to do that if you don't like. I just kind of prefer that look. Yeah, I think it looks cool. Anyway, that's it for advanced practice for this video. And next we are going to be learning about platformer or side-scrolling movement and jumping. Look forward to that. That's going to be kind of cool.